A very warm welcome, my dear children. We are in the second part of a lesson, metals and non-metals. In the first part, we have seen different physical properties of metals, such as metals are malleable, that is, metals can be beaten into thin sheets with a hammer without breaking. We call it as malleability. Metals are ductile, that is, metals can be drawn or stretched into thin wires. And metals are good conductors of heat with the help of different activities. Now we are going to start this part with a new property. Metals are good conductors of electricity. By saying that metals are good conductors of electricity, we mean that metals allow electricity or electric current to pass through them easily. This can be demonstrated with the help of an activity. We take a dry cell, a torch bulb fitted in the holder, and some connecting wires, that is, which are made up of copper, with a crocodile clips that can hold the metal or a non-metal piece to make an electric circuit. There is a gap between the ends of a crocodile clips so that the current flows in the incomplete circuit as shown. You can see that the bulb does not light if the substance which we have introduced between the crocodile clips is not a conductor. So let us start the activity. Aluminium foil, when it is placed between the two crocodile clips, the connecting wire, the bulb glows. Metal is a good conductor of electricity. Please note that connecting wires should be made in the arrangement as shown in the figure, and these are the connecting wires made up of copper metal. Copper connecting wires allow electric current to pass through them, so that copper metal is a good conductor of electricity. Take a bulb, fix two wires, one to the battery, one end, and to the other end of the battery connect the crocodile clips so that in between you can place the metallic piece. When you place an aluminum foil so that the bulb glows, this says that metal allows the electric current to pass through it. So as we know, silver metal is the best conductor of electricity and copper metal is the next best conductor of electricity. That is why electric wires, cables are made up of copper and aluminium metals, as they are good conductors of electricity. So we say that the electric wires that carry current in our homes are having a covering of plastic such as PVC, polyvinyl chloride, and it is an insulator so that we does not get shock through them. So on the outer part of the copper wires is wounded with a plastic wrap so that when we touch the electric wires we do not get shock, as the metals are good conductors of electricity. The next property, metals are lustrous, are shiny and can be polished. By saying the word lustrous, which means shiny surface, gold, silver and copper are shiny metals, so they are used for making all the decoration pieces and jewelry. A metal has a shining surface only when it is fresh. When a metal has been exposed to air for a long time, it gets dull appearance. It loses most of the shine or brightness. The metals lose their shininess or brightness on keeping in air for a long time, so that they acquire a dull appearance due to the formation of layer of oxides or sulfides on the upper surface. Object becomes shiny and bright once again. Metals are generally hard except sodium and potassium, which are soft metals. Coming to sodium and potassium are highly reactive metals. They are soft metals which can be stored in a fuels such as coconut oil, kerosene or petrol. Most of the metals are hard, but all the metals are not equally hard. The hardness varies from metal to metal. Most of the metals like iron, copper, aluminium are very hard. They cannot be cut with a knife. There are some exceptions as sodium and potassium. Take it on a watch glass, a piece of a sodium metal, and try to press it with the filter paper and try to cut it with a knife. You can see the sodium and potassium metal are so soft so that they can be easily cut into two pieces with the help of a knife. So they are very highly explosive, so we should not touch them with the help of our hands directly. The skin starts to burn. Not only that, when we put these sodium and potassium metals in the bucket of water, a big explosion takes place. So better we have to store them in a fuels. Next property, metals are strong except sodium and potassium, which are not strong. By saying that metals are strong, we mean that they can hold large weights without snapping or breaking. That is, iron in the form of a steel is very strong. Due to the iron metal, it is used for the construction of bridges, buildings, railway lines, machines, vehicles, and chains. Though most of the metals are strong, but some of the metals are not strong. Example, sodium and potassium. That is why they are not used in such constructions. Next property. Metals are solids at room temperatures except mercury, which is a liquid metal. Most of the metals like iron, copper, aluminium, silver, gold are solids at room temperature. Only metal mercury is in liquid state at room temperature. Next property, metals have high melting and boiling points except sodium and potassium, which have low melting and boiling points. For example, iron has high melting point. This means that solid iron melts and turns liquid iron on heating into molten form at 1535 degrees. Until that, it is very stable. Whereas sodium and potassium starts to get melted with 100 degrees so that they just gets molten. So the melting point of sodium is 98 degrees and potassium is 64 degrees. Gallium and cesium metals also have low melting points. These melting points of gallium and cesium metals are so low they start melting in the hand. The next property, metals have high densities except sodium and potassium, which have low densities. By saying the word they have high densities, we mean that metals are heavy substances. For example, density of iron is 7.8 grams per centimeter cube. This is quite high, so that the iron metal is a heavy substance. However, some exceptions for metals are sodium and potassium metals. They have low densities such as 0.97 grams per centimeter cube. So, we say that potassium and sodium have low densities, that is 0.97 grams per centimeter cube and 0.86 grams per centimeter cubes respectively. We also say sodium and potassium are known as light metals. Metals are sonorous in nature, that is why they are used for making bells, strings, wired instruments, musical such as sitar and violin and guitar. Next one, metals usually have silver or grey colors except copper and gold. Copper has reddish brown color and gold has yellow color. On the whole, we have completed the physical properties of metals. Let us take a review. Metals are hard. Metals are rigid. Metals are malleable. Metals are ductile. Metals are good conductors of heat. Metals are good conductors of electricity. Metals are lustrous and can be polished. Metals are strong. Metals are solids at room temperature except mercury. Metals have high melting and boiling points. Metals have high density. Metals are sonorous. Metals usually have a silver or grey color. Next, we are going to see with the physical properties of nonmetals. Children, nonmetals have the tendency to gain the electrons and become electronegative in nature. So metals lose electrons and become electropositive. Non-metals gain electrons and becomes electronegative. So some of the physical properties possessed by nonmetals are: nonmetals are neither malleable nor ductile. Nonmetals are brittle, that means they can be easily broken. Since nonmetals are non-bendable, they cannot be beaten with a hammer to form into thin sheets because they will be broken into pieces. That is, the property of being brittle or breaking easily is we call it as brittleness. A brittleness is a characteristic property of nonmetals. Please note that we can consider brittleness of a solid of nonmetals only. It is not applicable to liquid or gaseous nonmetals. It is only applicable to solid nonmetals. Nonmetals do not conduct electricity and heat, except there are few cases like graphite and carbon. Non-metals do not conduct electricity and heat because, unlike non-metals, they do not have free electrons. For example, sulfur and phosphorus are non-metals which do not conduct heat and electricity. Exception, carbon in the form of graphite is the only non-metal which is a good conductor of electricity. So let us perform with the help of an activity. Take a battery fixed to a bulb with the help of electrical wires which are made up of copper fitted to two crocodile clips. Now place a piece of sulfur, a non-metal, between these crocodile clips. Now allow the current to pass through it. So now you can see the bulb does not glow. This says that non-metals does not conduct electricity and they are poor conductors of electricity. Whereas graphite is an exception. When you take graphite in between, the bulb glows. This says that graphite is a good conductor of electricity. It is an exception of nonmetals. Non-metals are non-lustrous or non-shiny. They are very dull. Non-metals have dull appearance. Iodine is a non-metal having lustrous appearance. It is an exception. Non-metals, next property. Non-metals are generally soft except diamond, which is extremely hard non-metal. Most of the solid non-metals are quite soft. For example, sulfur and phosphorus are solid non-metals which are quite soft. Only one non-metal, carbon, in the form of diamond is very hard, whereas graphite is soft again. Diamond and graphite are the two allotropic forms of carbon, which is the hardest natural substance known. Next property. Non-metals are not strong. They can be easily broken. For example, take your pencil or a graphite, which is a non-metal, is not strong. It has low strength. When a large weight is placed on a graphite sheet, it gets snapped or it breaks into pieces. Next property. Non-metals may be solids, liquids or gases at the room temperature. Non-metals can exist in all three phases. Examples: carbon, sulfur, phosphorus are solid non-metals. Bromine is a liquid non-metal, whereas hydrogen and oxygen and chlorine gases are non-metals in the form of gases. Next property. Non-metals have comparatively low melting points and boiling points except diamond, which is a non-metal having high melting point and boiling point. Melting point of sulfur is 115 degrees, 115 degrees, which is quite low. The melting point of diamond is, however, more than 3500 degrees, which is very high. Next property. Non-metals have low densities, that is, non-metals are light substances. For example, density of sulfur is 2 grams per centimeter cube, which is quite low. Next one. Non-metals are non-sonorous. They do not produce sound when hit to an object. Example, take your pencil lead Only lead I told you children, which we use in drawing pencils. You just break it, you cannot hear any sound. Non-metals have different colors. The last property. For example, sulfur is yellow, phosphor is white. Phosphorus is white in color or red sometimes. Graphite is black. Chlorine is greenish yellow in color, whereas hydrogen and oxygen are colorless. So now we are going to see what are the properties of nonmetals, what we have discussed. Nonmetals are neither malleable nor ductile. Nonmetals do not conduct heat and electricity. Nonmetals are not lustrous. Nonmetals are not generally hard, they are very soft sometimes. Non-metals are not strong, they can be easily broken. Non-metals may be solids, liquids or gases at room temperature. Non-metals have comparatively low melting points and boiling points except diamond. Non-metals have low densities, that is non-metals are light substances. Last one, non-metals are non-sonorous and non-metals have many different colors. Now we are going to see what are the exceptions in physical properties in this. Electrical conductivities. We have studied that non-metals do not conduct electricity, but carbon is a non-metal, it is an exception. Carbon in the form of graphite can conduct electricity. Lustrous. Non-metals are generally having dull nature, that is they are non-lustrous, but non-metals such as iodine is a exception, it has a shiny surface. Hardness and softness. We studied that alkali metals are soft such as lithium, sodium and potassium, but generally all the metals are hard. Carbon is in the form of a diamond, generally non-metals are soft, but carbon in the form of diamond is an exception. Physical state. We studied that metals are generally solid except liquid mercury. That is, all the metals are solid except mercury is an exception. Whereas, all the non-metals may be in the form of solids, liquids, gases as we have seen. Melting points and boiling points. All the metals have high melting points and boiling points except sodium and phosphorus. Cesium and gallium have low melting points. I repeat children, please note down. Sodium, potassium, cesium and gallium have low melting points. Whereas in the non-metals are having low melting and boiling points, but diamond is an exception, which is a non-metal having a very high melting and boiling points. Coming to density, we have studied that metals have high densities, but alkali metals such as lithium, sodium and potassium are exception. They have low densities like non-metals. So this is how we can just distinguish between metals and non-metals, children. Please learn and write down in your notes. We'll just meet with the next session, chemical properties of metals. Please read the textbook and S-Chand if it is available. Thank you.